In this video, we're going to talk about something called piecewise functions, and in my experience, this is the topic that has caused many students trouble in several different classes I've taught over the years. It's a little bit different than what you expect. You have to get the notation down as well as understanding what to do with it, and it is something that will keep coming up in the future, especially in calculus class, so you really want to make sure you get it down. Now the idea is, in the previous video we saw how to graph specific formulas. If you have square root of x, it looks like this, and so on. But what if we don't want to restrict ourselves to just having one formula for our function? And you might say, well, why would we care about that? Well, there's many times in the world where things are going to change. So for example, let's say you are in your car driving and you're sitting at a stoplight. If you were to describe how fast your engine's moving, it would be a pretty boring, flat line. However, once the light turns green and you hit your pedal, right, so your kind of flat line here is going to suddenly increase because your engine has to work harder in order for you to accelerate. So just any time where you have one sort of behavior at one point in time, and then later you have a different behavior that's a very different formula, you're going to want to use piecewise functions. So again, the whole idea is I'm going to give you more than one formula, but you're going to use one formula for one piece of the graph and a different formula for a different piece of the graph. Now here's how the notation is going to look. You're going to have this little curly bracket here, which tells you that it's a piecewise function. You are going to have all the different formulas you may be given. In this case, there are two formulas given. And then over here on the right side is going to tell you the rule for when to use which formula. And the rule is always going to be based off of x values. So in this case here, it says that when x is a number that is less than or equal to 0, you are going to use the formula absolute value of x. And when your x is a number that is bigger than 0, you are going to use the formula x squared. And so the idea is that depending on what x value you have, you are going to use different formulas to find the y value. Before I do an actual graph here, let me go ahead and just do a calculation. Let's suppose for this function, I ask you to tell me what f of 2 is. So I want to know what happens when you plug in an x value of 2, what y value are you going to get? Well, the thing is, you have two different formulas, and it would give you two different answers, but only one of them is correct. So you have to ask yourself, my input here, my x, which rule does it follow? Well, x being 2 is a number that is bigger than 0, so therefore we use the second rule there, and we would square it, and the correct output here would be 4. On the other hand, if you were to plug in -2 into your function, then in this case the x value is a negative number, so it goes along with this rule. So then we use the absolute value function, and we do not get an output of -2 squared, we get an output of just 2 here. So again, the whole point of piecewise is you can use different formulas in the same graph, and you're just going to tell you which piece of each graph you want. Now, if I want to draw a graph of these, which is what's usually going to happen, then there's a little bit of a shortcut we can use here. So what I'm going to do is I'm going to use green for this top graph here, and I'm going to start by just writing the entire graph. We know absolute value x is our V-shaped here, so I draw the whole thing first. Then I ask myself, well, okay, I don't want the whole graph, I only want a piece of it, and I want the piece of it where my x is less than or equal to 0. So then I look on my graph here and say, okay, which part of this is x less than or equal to 0? That would be the left side of the graph. And what that means is I don't want the right side anymore, I'm just going to go ahead and erase it. Right? I only want a piece of the graph, not the entire graph. So what do we do now? We now look at the second formula, and I'll use purple for this. This is the x squared graph of parabola. we know what that looks like. It looks something like this. But then I ask myself, what part of it do I want? I want the part of it where x is greater than 0. That's this right-hand side part here. So then I go ahead and get rid of the part that I don't want, which is the left side. And then, let me just make it look nicer here. Combine it together, that means I have the absolute value on the left side, nice straight line, and on the right side I have my parabola. Now again, depending on how careful you are with graphing these, it may look like it's a parabola still, but let me do it one more time here. The left side is a nice straight line, and the right side is a parabola. So you see where you're using two different formulas in the same graph, we're just using one piece of each. Now let's do the same thing over here. So we have first the graph 1 over x. I'll use green again. 1 over x looks like this. We only want the piece of it though where x is less than 0, so we want this piece right here. And then we want the second function is 2x minus 1. That's a nice straight line with a slope of 2 and a y-intercept of -1. But we only want the part of it where x is greater than or equal to 0. So that would be that part. Now again, the blue is the actual answer. I will go ahead and erase the other part because again, that's not part of the answer. That's just our guide to help us draw the answer. And if you want to get good at this, you can draw it without having those separate blue and green. Just know which piece you want of each of them. But regardless, this is the shape that we're trying to look. And the nice thing about this is we are able to draw a graph that there is no single formula that would ever give us that same graph. Okay, there's no single formula that's not piecewise that would allow us to have a graph that looked like this weird shape. So whenever you want to get examples in calculus where things don't work out quite nicely, piecewise is going to be your go-to type of function to use. Okay, now I told you that we can have any number of different formulas here, and you'll notice this next two examples, they have 3 formulas each. So that means we're going to have 3 separate pieces. And I am going to try to save a little bit of time here by skipping the drawing each one separately and just taking the piece I need. So this first one here, it's a constant function of -1, which means it's going to start out just being a y value of -1, and that's going to happen every point up until x gets to 0. Now, I specifically want all the things where x is less than 0, not equal to 0. What that means is it doesn't quite reach the x equal to 0 part there, and that's why I put a little circle, an open circle there, to indicate that it's getting close to that, but it never quite makes it there. If I did actually make it there, I would have filled in that circle, and that's what we would have. Okay, the next thing I see is I see the square root function. I know what that looks like, but this time we're only going from 0 to 1. So it's just this little teeny piece of the square root function that we're going to have. And then after that is the x function, which is then going to go straight off here. And this is what we have for this function. And I do want to point out that you see sometimes the pieces might join up together no problem, and sometimes the pieces will not join together. And it's just a coincidence on what functions and numbers are specifically chosen for the problem. You should not expect one way or the other here. Now we have our last one. It says for x is less than -1, it's the parabola, so it looks something like this here. Got a nice little parabola. Then it's going to go to the graph of y equal to -x. Now, that's a line with a negative slope and a y-intercept of 0. And if you were to refill that, it's going to go all the way back there, filling in that hole. And then we're going to go to 2 here, and we have an open hole. And then lastly, we have the absolute value function, which if I imagine it, being the V shape here, it's going to go something like this. And this thing is going to be our function here. So you see piecewise graphs, they really test whether you understand all of the steps of graphing, all the different things in your library of functions, and then you need to know how to take which piece of which graph. This is definitely something I recommend practicing a good bit before you take a test on it.